Okay, so this problem is actually going to take a couple of different questions that you will see into just one problem. And that first question is to figure out what a missing probability would be if you have a discrete random variable. So in this case, we have that x is equal to the number of televisions per household in a small town. And it looks like some people have none, some have one. There's another percentage or proportion that we're not sure of just yet that have two. And then a majority, because it's more than half, have three. So to figure out what this probability is, what's the probability that x is equal to 2? Remember that the sum of all of our probabilities has to be 1. Therefore, I could do 1 minus 0.03 plus 0.15 plus 0.51. And so if I do that, now either keep subtracting, so I usually forget parentheses. So when I put this in my calculator, I might say 1 minus 0.03 minus 0.15 minus 0.51. Or I need to use the parentheses. But in either case, I'm getting 0.31. So that would be our probability for exactly 2 televisions in a household. So if we were, I guess another question you might see is also just what is the probability of, that x is equal, let me erase that, probability of someone, or I guess a household, sorry. So I liked having these typed out. Probability of a household having 1 or 2 TVs. There we go. And so that would just be, what constitutes 1 or 2. It's those two together. So the probability that x equals 1 or 2, I would add 0.15 and 0.31. Remember, that's the nice part of the discrete random variable, is that everything is disjoint. So all I have to do is add. I don't have to worry about there being any overlap, because you can't. Someone can't have exactly 1 and exactly 2 televisions in their household. All right. So the other type of question that you'll see with this, so there'll actually be at least 2 different questions. One of them finding the missing probability. Another one where you have all of the numbers actually already filled in, and then you're asked to find, a compound probability. That just means more than just reading off, one of these numbers specifically. Compound is just going to be that or. And then one of the questions that you answer online, that's when you're going to come in and also do number 2 on the paper portion of the test. And I'm going to see, can I move? Yeah, there we go. Whoop, don't want to move up too much. There we go. So I just want to be able to make sure I can scale my axes here. So in this case, if you remember, I typically like to let 0 kind of be over just a little bit, because it's hard to have, your labels and your tick marks going along the vertical axis and have a line on that axis. So in this specific case, we're not going to let the y-axis be where x equals 0. We're going to scooch it over just a bit. I need, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I might let every other one. Since I just have to get 0.51, it's not too bad. Whoop. There we go. Sorry about that. And so 1, 2, 3. Of course, I do want to label this as well. So this would be number of TVs. And then remember, for a discrete random variable, we want to, or discrete probability distribution, same thing. Discrete probability distribution shows the graph of a discrete random variable. I just want a straight line, a vertical line above each of these numbers, 0, 1, 2, and 3, that tells me what my probability is for each one. So 0.03, if every line there is a 0.05, then I'm kind of a little more than halfway. 0.15, that actually would be exactly between the 0.1 and the 0.2. I found this 0.31, so just a little bit above the line there. And then 0.51, so that's going to be just a little bit above the top of my graph. So that's what I'm looking for when I ask you to graph or sketch this discrete probability distribution. It'll say provided in question number whatever. That's what I want to see. Make sure you label and scale your axes. So, labeling, that's putting the probability and the number of TVs. And let's use a different color. Scaling, that's having the correct numbers along your axes. So that's what that question is asking about.